Hello, welcome to my YouTube channel. So in this video, I'm going to solve the first question here, which reads, find the volume of the solid that is bounded above by z equal to x squared and below by the region enclosed by the parabola there, which is y equal to 2 minus x squared, and the line y is equal to x in the xy plane. Okay, so if you're new to my channel, kindly subscribe, okay, as I'll keep posting similar videos several times. Okay, so in this video, I want to focus on the first question, but soon I'll also post the next question. Okay, I'll make a video the next question. So let's get started. So we are told that this region, the solid you want to find the volume, is bounded above by z squared and is bounded below by the region enclosed by y is equal to 2 minus x squared and the line y is equal to x, and this region, okay, y is equal to 2 minus x squared and y is equal to x is in the xy plane. Okay, so the region is in the xy plane, and then above it's bounded by z is equal to x squared. So we need to find the boundaries in the xy plane. Okay, so let me first sketch this region. Okay, so in the xy plane, so I'll draw the xy axis. So y-axis is here, and then you have the x-axis. Okay, so you have the parabola y is equal to 2 minus x squared. Okay, y is equal to 2 minus x squared, and this parabola faces downward because the coefficient of x squared is negative, and it crosses the y-axis at 2, as you can see here. Okay, the constant term, that's where the parabola crosses the y-axis. So it crosses the y-axis at 2. Okay, so this may not be the exact, but just a sketch. Okay, so this are 2. And also you have this line, y is equal to x. Y is equal to x in the line that passes through the origin at 45 degrees. Okay, so it's bounded, this region is bounded by y is equal to 2 minus x squared, which is a parabola, and also y is equal to x. And you can see this is the region that we're interested in. So I'll label this region as region D. Okay, so within this region, now we have to find the boundaries. Okay, the boundaries in x as well as the boundaries in y. So if you notice very well, we can choose, right? Okay, to have the limits of y from the line to the curve. Okay, so we're going to get the limits of y from the line to the curve. What the limits for x will be the minimum value or the lowest value in this region, and that happens at this point. And the maximum value happens at this point here. Okay, so we can have those limits here. So we need to get the value of x at this point and the value of x at that point. While y will come from the lower line here to the curve. So I'll say y is from y is equal to x. So the boundary is for y from y equal to x to the curve, which is 2 minus x squared. Okay, what are the limits for x? How do we get these limits for x? We're going to get these limits for x by solving these two equations simultaneously. So I'm going to equate these equations equal to each other. So I'll solve 2 minus x squared equal to x. Okay, so if I move x squared other side, you have x squared plus x, and then also I move 2 minus 2 equal to 0. Okay, so we can in fact factorize this, the product, simply negative 2 sum is positive 1, factors that is negative 1 and positive 2. Okay, those are the factors of negative 2 equal to 0, and then we're going to have x equal to 1 or x equal to negative 2. So this means that the lowest value of x here happens at negative 2. Okay, so this at negative 2, and then this happens at positive 1. Okay, so those will be our limits for x. So x from negative 2 as the lowest value to 1. So now having done that, we can set up our integral. Okay, while the top part or the top bound will be our integrand, the function you're going to integrate. Okay, so every time you're integrating, make sure that the limits that involve constant values is done at last. Okay, so negative 2 to positive 1, and then the variable limits, you have x to 2 minus x squared. Okay, our integrand is x squared, and this, since the innermost limits are limits for y, so we're going to the order with the y dx. Okay, then let us integrate this with respect to y. So we're going to treat x as a constant. Okay, so treat x as a constant. So this will be x squared y, because the integral of a constant just going to add that variable we're integrating with respect to. Okay, so we have x 2 minus x squared, and then we have to do this with respect to x. Okay, so we substitute the limits of integration, negative 2 to positive 1, x squared, the upper limit is 2 minus x squared minus also x squared. The lower limit is simply x. And then we evaluate this with respect to x. Okay, so let us expand. So the expansion of that, we have negative 2, positive 1. This is 2x squared minus x to the power 4, and then minus x power 3 dx. Okay, let's integrate with respect to x. Negative 2 to 1. This is 2x cubed over 3 minus x to the power 5 over 5 minus x to the power 4 over 4. Sorry, I need to get rid of this integral every time I do the integration. Okay, just forget that. And then the limits from negative 2 to positive 1. Okay, so we substitute the upper limit first. So we substitute 2 times 1 cubed over 3 minus 1 to the power 5 over 5 minus 1 to the power 4 over 4. That's for the upper limit. Minus the lower limit, we have 2, negative 2 to the power 3 over 3 minus negative 2 to the power 5 over 5 minus negative 2 to the power 4 over 4. Okay, so 1 to the power 3 is simply 1, so I have 2/3. 1 to the power 5 is 1 over 5 minus 1 over 4. The lower limit, negative 2 to the power 3, that's negative 8. Okay, negative 8 by 2, I have negative 16 over 3. Negative 2 to the power 5, that is negative 32. Okay, negative 32 by this negative way, we have plus 32 over 5. Finally, negative 2 to the power 4, that is positive 16. Okay, positive 16 divided by 4, that is just a 4. Okay, so we can just get our calculator and punch that. So 2 over 3 a minus 1 over 5 minus 1 over 4. This gives me 13 over 60 minus negative 16 over 3 plus the 2 over 5 and then minus 4. This gives me negative 236 over 15. And then this is negative. We're going to add these two. So this will just be 13 over 60 plus 236 over 15. Okay, so 13 over 60 plus 236 over 15. The result is 319 over 20. And double integral always actually, we find the volume of a solid. So this is it, units cubed. Okay, so that is a solution. And thank you for watching. Kindly check after some time or after a day. I'm going to post another video on the, I'm going to post the next video. Okay, thank you for watching and please subscribe to my channel.